Alright, so we're going to be working with fractions again today. So I have a little video that will kind of introduce you to what we're going to be working on.
Can you turn off the lights?
No, you don't need to.
Oh, yeah.
If you turn on that little speaker thing.
That video was kind of silly, but it really talks about what we're going to work on today. So what was that word that he kept repeating over and over and over again?
Apple. Hopefully I can get it. Oh, wait, no.
The one word. Yep, decompose. So we're going to be decomposing fractions. So your morning work was talking about adding the fractions, but we're going to decompose a single fraction into smaller units. So to help us out, we're going to be using some manipulatives and materials today. So I need you all to come and get one of these and take it back to your seat. And you have 2 minutes, about 2 minutes, to just kind of get used to working with them. Yep, every person gets one.
I need a new one. My one hole doesn't have a one hole on it. Or does it? Wait. No, it doesn't.
They should be all the same. They might be leaving on the other side or on the parts that you can't see.
That one has a one on it. But this one only has like one hole.
Yep, that's the same thing as saying one.
This is almost sentence.
The other side has
But there's only one unit.
it might be on the side that you can't see.
Why did I break it?
one of them, right? So only Minecraft will just know that it's one. Alright, Alexis, can I have you move to your desk now? Let's pick everything apart. How do you know it's none of them had 7. Because those ones aren't because you can make the 10 with towel. Alrighty, 4th graders, I need your attention, so I need you to put all of your blocks back on your table flat. No more towers.
Or swords.
Or swords.
Taking them apart.
I'll talk about that. Okay, so once Jason and Danny put all their blocks down, we'll get started again. Okay, so 4th graders. Some of you have noticed and brought it to my attention that there are no 7ths and there are no 9ths in this. Now, does anybody have an idea of why there would be no 7ths or no 9ths? Math.
Because you can't split 7 to 9.
Right, you can't really split them up like you can the 10ths and the 4ths and the 3rds. None of them, the 7th and the 9th, are not really equal to any other one. Yes, Jen? Yeah, 11th either. So these ones just go up to 10th and then it skips to 12th. Alright. So, we are going to start. I need you to have your red 1 block, your orange colored 3rds, and your teal colored 6th. So make sure those are like at the front of the desk. We'll work with those first. I don't have a teal. I'm still building teal. Yes, you do. Yes, you Yes, you do. Okay, so 4th graders, I need your attention. So if I put the 1 block down, and then I put the 3rd next to it, what can I say about the size of them? They're the same, good. Alright, now, what if I break off, and you can break off with me, what if I just break off 1 part, 1/3 from the other one? How much is over here? How many actually? And how much is over here? 1/3. Awesome. So I'm going to put them back together. And how many do I have all together? What can I call that?
1 whole.
1 whole. Now we're going to take our 6 and put your 6 next to your 3rd as well. Alright, so what do you notice about your 6? Yeah, Jane.
2 6.
Great, so if I break off this 1/3, and if I break off this, the 6, if I break them all apart, how many would it take to be the same size as our 1/3? Yeah, Liz. 2. So if I put 2 of the 6 together, and I put them next to 1/3, are they the same size? Yeah, they are, right? So all that the blocks did is that they split the 3rds into 2. So each 3rd is split in half to give you your 6, because there's 6 parts now, right? Alright, so we're going to draw this into a tape diagram now. So I need you to get your whiteboards out. Alright, give me a thumbs up if you have your whiteboard on your desk. Okay, we'll wait 1 more minute. All right, fourth graders. So I'm gonna draw one hole to represent my red. So that's one hole. Now we're gonna divide it into 3 equal parts. When we divide it into 3, what is that representing? Thirds. Yeah, somebody said that. Awesome. Okay, thirds. Now we're gonna divide and decompose each of these thirds into 2. So just divide each third into 2 parts. Now, how many parts are there? How many parts do we have? Only 3 people know how many parts we have on our papers. Yes, Jackson. 6, right. Okay. So we were talking about earlier that with our blocks, it takes 2 6 to equal that 1/3. So we're going to shade in our 2 6. All right. Now I need you to grab your black stack of blocks. And these should say 1/12 on them. So these are representing your 12. If you were to punch in 1 divided by 12 on a calculator, that's what you would see. You would see the 0.08.
I like this.
So we're going to focus on the fraction side though. So on our picture, I need you to divide each part in half one more time. So we're going to decompose each 6 into 2 equal parts. Now, how many small parts do we have to make up our whole? How many small parts do we have? Ariane. 12, great. And how many of those 12 are shaded in? 4, Ashton, right. So that means how many 12s are equal to 1/3? Because remember, we shaded in the part that was equal to 1/3. So how many parts are equal to 1/3? Cool. How many of our small parts are equal to our 1/3? So if we look at all of these small blocks right here. Yep, 4/12 is equal to 1/3. All right. Now I need you to clear off your whiteboard and put your 3rd, 6th, and 12th to the side. And I need you to grab your block that says 1/5 on them. They should be green.
I need a rainbow.
Give me a thumbs up when you have your green blocks. Okay, awesome.
Ariane,
I
reset.
see all these green blocks. We are going to draw our tape diagram. So draw your big rectangle to represent your one hole. So this looks just like our red block, right? Okay, so now we're going to divide it into 5 equal parts. What do these 5 equal parts represent? Yes, Brandon.
How many holes are
Can you say that a little bit louder?
5? How many holes are 1/5?
How many holes? Do you mean how many fifths are in one hole?
Yeah.
Yeah? Okay, so how many fifths are in one hole then? 5. Great. Okay, now we're going to decompose each fifth into 3 equal parts. So instead of dividing them right in half, you're going to make each of these 3 parts, okay? So we can draw the lines like that. So each block should end up looking like this.
Draw 2 lines within the block.
Yep, draw 2 lines inside of each block. So then you'll have 3 equal parts in each block. Alright, so how many small parts? Jackson, do you have a question? Okay. How many small parts are there, Jackson? 15. Great. Okay. So, I need you to talk with your tables about how many of these 15ths would equal 1/5. Okay? How many 15ths would equal 1/5? You have about a minute to talk with your table.
Every 2 lines.
How many of these 15ths would equal 1/5?
That's about right. So maybe like 3. Yes.
And what were you? Alright, what is that? So then how many? How many of those 15? Remember, this is 1
No, this is
So that 1/3. No, it just does that. Yeah. Okay. I just wanted to make sure. Yeah, that's all right. As long as you had enough Okay. So, group 3. Can you tell me how many 15ths are in 1/5? Allie.
3. Oh. I thought you caught in the whole group.
What was it, Allie? 3. Awesome. So we're gonna shade in these 3 15ths. Okay. So, how can we write this as an addition problem, as a number sentence? Jack. And what would that equal? Danny?
1/3.
How much would it equal? We shaded in on 3 parts. 1/5. Alright. So then, what can we say about 1/5 and 3/15? Only one person knows what we can say about 1/5 and 3/15. Yes. What do you mean? Ashton, reset.
And the 50 goes on 2. What you would do is you would add that 1 to.
So if we added another 1/15, we would have 4 15s, right?
So like add the 1/5 to 3/15.
But 1/5 is equal to how many 15s? 3/15, right? So that's what Jackson is saying. 1/5 is equal to 3/15. Now, how can we write this as a multiplication problem? Brandon.
3 times 5 equals 15.
Well, yes, 3 times 5 does equal 15, but how can we write the fractions with multiplication? Grogan.
3 times 1/5.
3 times how much?
1/5.
But if our 1/15 is equal 1/15, right? So 3 times 1/15 equals our 1/10. Does everybody see how that happened? Here, Brandon, get it. All right. We're gonna try one more together. Okay. We're gonna work with our 6 and our 3rd. Actually, our 6 and our 12.
Oh, my phone.
Alright guys, I just need to say, remember these are tools, not toys. Some of you I feel are treating them like toys. So if that's the case, then they get put away. These are tools, not toys.
Alright. If I was to write 2/6 equals 1/12 plus 1/12 plus 1/12 plus 1/12 equals 4/12. How can I show that that is true? So I want you to work with your tables and draw it out on your whiteboard or use your blocks to show how you know that 2/6 equals 1/12 plus 1/12 plus 1/12 plus 1/12 or 4/12. So work with your tables to see and show how those are equal. So you have about 2 minutes to work with each other. How can you show that that is true? So how can you say how can you show? Do you draw it or use your blocks? You can do either of those. Draw your tape diagram. Try that. Try to draw it. You want to show me? That's a good thought. You want to use that with your tape diagram or your block. You can show the class too, okay?
I just froze as well. Look. I just showed you my block 3 times.
Yep. Is that what you were doing too? Yep. All right, I'm seeing a lot of great ways to show that 2/6 equals 4/12. Now Jackson had an interesting way of doing it. Can you come up here and show us how to do it? Do you need the thirds? Or you can draw it if you want to draw it. Speak loud so we can all hear you.
Technically, all three, if you just break them up into thirds. They're all equal because they're all equal to 1/3.
And how do you know that they're all equal to 1/3? Because they're the same size. Awesome. Thank you, Jackson. Alright, did anybody do it a different way? Yeah, me.
When I did it, like I did 4
Did anybody do it with a tape diagram? Draw it out. Jocelyn, you did. Do you want to show it up here? So what did you do first? Alright, so she drew her sixes, her six first.
And then I went through 1 and 2.
So then she split each six into two, so she was decomposing her six.
So then I colored two sixes. So then that would mean from those would be 2 to 6s and that would be 1, 2, 3, 4. 4 colored in from the 12. So see, how 4 is supposed to be colored in from the 12 and 2 is colored in from the 6.
Does everybody see how she did it with the tape diagram?
Yeah.
So she drew her six and knew the color in the 2 6, and then she split into 12. So then she saw that 4 of the 12s were then colored in, so that equals her 2 6. Alright, thank you, Jocelyn. Okay. So I need a thumbs up or thumbs down if you think, yes, I can decompose any fraction that I'm given into a smaller fraction. Or a thumbs down if you're like, I don't really know how to decompose my fractions. Alrighty. We're going to work on one more problem to get used to this idea of decomposing our fractions. I need you to get your halves, which are pink, your fourths, which are yellow, and your eighths, which are blue, dark blue.
Um,
Nope, you need this. No, you're good. You know how many parts are in this whole. So then one of these. You know that. Okay? Alright. So, we are going to see how many, we're going to see how many eighths are in 1/2. Okay? So if I draw my tape diagram, I'm going to divide it in half. I'm just worried about the halves now. Yes, Rosie? You know what it is already? Okay, well we're going to work with the tape diagram first. And then we'll see if everybody else gets the same answer as you. Okay, Rogan? Alright, so I'm going to shade in this 1/2. Because I want to know how many eighths are in that 1/2. So to get to my eighth, I could just divide them, decompose the halves into the 8 pieces. But I'm going to start with the fourth. So I'm going to decompose each half into 2. So now how many parts do I have in this whole? Only 2 people know how many parts are in my whole? Jason. 4 parts are in my whole. Now how many of those parts are shaded in? Brandon.
2.
2. Great. So now we're going to decompose our fourths into 2. Now how many parts do we have, Ariane? 8. And how many of those 8 are shaded in? 4. So then if we have 4 right here, how many eighths then are in 1/2? Because what part did we shade in at the beginning? Rogan.
You shaded 2 at the half.
Mm-hmm.
And 8 is 4 is half for the 8.
So how can I write it? 1/2, can I say, equals how many eighths? 4 eighths. Did that one help a little bit? Does that make a little bit more sense on how to decompose our fractions? Yes? Alright, so we are going to start working on a problem set. And you can work with the people at your table, or you can work by yourself. You can draw out the tape diagrams on your whiteboard. You can use the manipulatives to help you. Whatever works best for you to figure out how to decompose a fraction. Part A of number 1, they did for you as an example. So we're going to finish 1 together by doing part 2.
Do I go with Miss Rain today?
No, she's got some things going on. I mean, if she comes, then yes, but I don't think we will. Okay.
You can still use the blocks, so you don't have to put them up.
I don't need them.
Okay. Yeah, then put them in your bag. Okay, fourth graders. So I said that they did part A with us, for us, right? Yes. So I can see that for part A, they divided it into half first because they have the half written at the top. Is everybody ready?
No. Yes. I'm ready. Yes.
Okay, let's keep going. Then they split up each half in half again, right? That's what the second dotted line means. So since they have that 1/2 shaded in, you can see then that 1/4 equals 1/2, or 2/4 equal 1/2. So they have 1/4 plus 1/4 equals 1/2. And then I see over here that they split the fourth again. So now how many parts are there? I can count and I see 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 parts in the whole now. And in that shaded area, there's 4 of those parts. So I can say that 1/8 plus 1/8 plus 1/8 plus 1/8 equals the 1/2. Okay? So now I'm going to work on part B, and if you can follow along, that would be great. So they have this split into 3 parts. And then they split each of those 3 parts into 2. So I see that there's 1, 2, 3, 4, 5, 6 parts in our whole. And 2 of those small parts are in the shaded area. So I can say that 1/6 plus 1/6 equals our 1/3. Because the small parts are now, there's 6 of them. So 2 of the 6 are here, and that equals the shaded 1/3 here. And then in the next part of part B, they split the 6 again. So now there's 12 whole pieces, I see. So I know that each of these little pieces is one of those 12. So since each of those small pieces are 1/12, so I see that 4 of them are in that shaded area for 1/3. So then I can say that the 1/12 plus the 1/12 plus the 1/12 plus the 1/12 equals 1/3. Thank you, Jason.
So how many 12s equal 1/3 then? Jackson? 4. So 4 what? 4 12s equals 1/3. Very good.
Then you can write that over here as well. Okay? So finish up the problem set with your table. And if you finish in the next 10-ish minutes, then you can come and grab the exit ticket. But if you aren't done when time is up, I will give you your exit ticket. Okay? And you'll work on that for homework. But right now you can work on the problem set with your group.
Okay.
Yes, you're good.
Do you have to do this for homework too?
No. Finish as much of this as you can get done in the next few minutes. What do you mean how to see it? Yep, right here is 2 6. See? 1, 2, 3, 4, 5, 6. So 2 of those 6 are shaded in. Right? says 1/3 was that they split this up into. Can you read that real quick? So they kind of skipped. Well, it's in there, but you can. So they split it up into thirds first. So see how there's 3 parts. So they first split up into thirds, but then they show you that they split everything up into 6. Okay. And so then they had that 1/3 shaded into it, and then they went to this step and divided it all into 6. Okay. Yep. Like as much as you can get done now. So then you can use your on your Okay. So it's a little bit confusing on what they want you to do for C. So can somebody read me the directions? Rogan, you can read the directions for it.
The point of each shaped diagram represents one whole. Decompose the shaded unit fractions as the sum of smaller unit fractions in at least 2 different ways. The first one is
So they did the first one with decomposing it into the smaller pieces, right? So now you need to do that on your own. So for C, they have it split into the 4 pieces. So you know this shaded area represents how much of that whole? Danny.
1/4.
1/4. So you can write the 1/4 above the shaded area. Now in parts A and B, they already had those dashed lines for you. Now it's your turn to draw in those dashed lines. So you're gonna decompose each one. So now how many pieces are there? Jason.
8.
There's 8. And how many of those 8 are in the shaded part? Only 2 people know how many of those 8 are in the shaded part? Jocelyn.
2.
2. So we know that 2/8 then is equal to 1/4. Now for the second part of C, you have to divide them again. So you'll divide each 8 into 2 pieces. So then how many pieces do you have total? Liv, how many pieces do you have total here? Huh? 12. Did you split yours into 3 equal pieces? No. Did you? Let's see. Does each of your boxes look like that? Maybe. Where you have 3 pieces in each box. Do you have 4 pieces in each box? So how many are in the total then? 16. Right. So then how many of those 16ths are in that shaded area, Liz? 4. So how can you say that as a fraction? 4/16. And that equals how much of that big part that they first split up for you? Liz? 1/4. So 4/16 equals 1/4. Okay? So for D, you can divide them into the smaller parts again. And same thing with 2. And on the back, you're going to have to do your own.
Stay flat. I don't want you to fall.
So you can work with your tables if you need help or ask any questions.
We've got about 5 minutes before
Okay.
fine arts.
So do you guys remember that last time I had you answer some questions for me?
Yeah.
I'm going to need you to answer somewhat similar, somewhat different questions, okay? So I'm going to hand you your exit ticket, which you'll have to complete for homework, but I need you to answer these questions first as well, okay? And since we don't have much time, I'm going to have you work on the problem set for homework as well, okay?
You guys should have some time. We've got checkout after fine arts, and then those people that have book fair money are going to be able to shop. But as soon as you come back, you have time to work on that before we go out to brain break. So you'll have a little bit of extra time, okay?
Yes. Please answer the questions first. That will be step 1.
Wait, do we write down the answers on the back?
Yes. Sorry.
On what one?
The extra ticket. The red one on the back. Which one? D. Dividing it into its own parts. A fraction. So,
Oh, okay.
so I divided this one into. So then I just used that as well over here. I went ahead and divided it into half. So I'm going to do one a different way. I'm going to do 8 in half again. Actually, one more time.
No, 5th grade has our 50s. Because she's got to test 80 kids. Yeah. So she borrowed last year too. Yeah, but she's had them for like 3 weeks. So if you could tell her to try to have them back to us by next week, or yeah.
So we first divided it and then shaded it. And then they went ahead and divided it again for you. And then they divided it again.
Now it's saying to do it in 2 different ways. So you could decompose this one in 2 different ways. So this, this here is kind of has it in 2 different ways here as well. So it looks like that's what you'd be doing. Well, no, because this one they had you do it one way. This one you did it in 8, and this one you did it in 16. The only thing I would tell you to do is you kind of put your boxes there. Sometimes it's easier if you actually draw them in there. That would be my only suggestion. But everything else is good.
How much is this? 4, yeah.
I like the sticks. I don't have an answer for number 1.
Okay, then write something that you like.
I like these things.
Ariane, that needs to be put away. You need to be working on your work.
Sure.
Oh yeah. I think I've seen her.
Can you do the questions first? Oh, you didn't? Finish with
So maybe once they're done writing the answers to their questions, you could have them line up for fine arts.
Did you do the questions first? No. Okay, can you do the questions first and then we can get that? Well, that's fine. Yes? Okay. Okay, fourth graders, take 2 more minutes to answer the questions, and then you can line up for fine arts when you are all done.
Things like that.
And you can leave your papers on your desk. I'm just gonna be here. Are you? No. Yes.
What do you do?
Line up. When you're all done with the questions, you may line up. Thank you. It's up there. R.
Certain ones that go on here, certain ones that don't. So, thank you. You're good. Once your questions are there, go ahead and write them, okay?
All right, fourth graders, I need you to quickly finish these up so that we are not late to fine arts.
What do we do with that?